Hi, my name is Steve Souders. I work here at Google on web performance. And today I'm excited to have this talk about two open source projects that I was involved in getting out this week. I announced them at the Ajax experience earlier this week in Boston. So this is going to be one of the tech talks that's part of the Web Exponents speaker series. And I'll blog about it on Google Code after we're done. But if you want to check out that Web Exponents playlist, and we've got people like John Resig and Doug Crockford and Asa Raskin and Ben and Dion from Ajaxian and other people like that. So it's a good set of tech talks. So this tech talk is going to cover these two projects, Browserscope and SpriteMe. SpriteMe is a spriting tool that I kind of did on the side out of a source of frustration that I'll talk about in the second half. But in the first half, I wanted to cover what I think is the largely, vastly a much more important project, Browserscope. And I'm totally, extremely excited because my office mate, Lindsey Simon, a few months ago agreed to take over this project and shepherd it to launch and keep it going. And so he's going to talk about Browserscope in the first half of this talk. So without any further ado, please help me welcome Lindsey Simon.
Hey, so I'm Lindsey Simon. I'm a web developer on the user experience team, and so I work a lot on the front end. So I spend a lot of my time in browsers. And one of the things that means is you have to learn about how they operate in the wild. And usually, that's testing your own sites or going to sites like QuarksMode or Ajaxian and seeing what the state of the art is in text. That can be a problem because the browsers change very quickly. New builds of Firefox come out every other day, or there's nightlies, and Chrome and WebKit are coming out much more swiftly than we're used to dealing with in the web development world. But we're also very excited about that. So Browserscope is a project to try to capture historically the capabilities of browsers at given releases, and also to publish that data. So let's go. This is the website itself. This is Browserscope. You can see we've got some categories here to click on, and you can also see that these are people running the tests on their computers at home or at work, and you can see sort of the flow of test times here. So they're happening pretty frequently. People are participating. All right. Sorry about my nubbin skills. All right. So what is it? Browserscope, we've talked about, this is an open source project that lives on Google Code. We're saying it's a community-driven project for two reasons. One, because users participate in this, not in controlled environments, but on their machines and in their wherever they are on the internet. Also, it's community-driven because the tests are open to the public. So you can go read the code for the tests if you have an issue with how they work. You can suggest new ones. You can write new tests. And that's something we're actively encouraging and hope happens. So these are our goals. We want to foster browser innovation by publishing and publicizing these metrics. Hopefully, we'll see vendors try to improve on their scores and solve problems that we're identifying. We also, like I said, want to be a resource for web developers to see how browsers do and don't operate in the wild, and given the current version numbers, not on a site like QuarksMode, say, where it requires somebody to manually update. This is an automated updated site. So we're trying to provide that resource as well. And I'm going to say this is not to be in competition with sites like QuarksMode. We can't do what QuarksMode does in an automated way. PPK is a master of this, but also, he is a human and has limited time to be able to update every page on his site at once. So that is a challenge. The key characteristics here is that Browserscope is more of a matrix than it is a benchmark. We're not really trying to just give you a final score all the time. We're trying to show you capabilities across different tests and give you a sense of what browsers do well and what they don't do well. Like I said before, reproducible results are really key here. We're testing for capabilities and not performance. And this comes back sort of to where we started talking. Me and Steve were talking about what Browserscope would be good for. And this is around the time that IE8 had released a performance video going through the 100 most popular websites and showing with their test lab how much better IE8 was than other browsers at this. Of course, that's very difficult to reproduce. You need the machine, you need the conditions, you need the software, and if those aren't readily available, you just have to take the video on its word. And of course, we're scientists. We want to test things. We want to poke at things. So that doesn't cut it for us. So Browserscope, again, you should always be able to go to reproduce results on these tests, and they shouldn't be based on your processor or how good your internet connection is. So the Browserscope itself really is a framework underneath for just capturing and storing this data at a high rate and spreading out what's basically a complicated median tree and handling that for our developers, mainly people writing tests. We want to be able to capture these historical trends, one, because they're just cool to look at, and I'll show you an example, and also to try to uncover regressions. Maybe one test passes today in WebKit, and tomorrow's nightly it doesn't. Well, we can capture that if we store that information and present it. Browserscope has close to zero operating costs. It takes, right now it's running on Google App Engine, and I'll talk a little more about that later, but it's running in the cloud. It can, we're not having to pay for hosting conveniently since Google's sponsoring that. And so it's not tied to any one individual developer participating. This can go on if I get hit by a train tomorrow. Somebody can just take up the Google Code project and do another push to App Engine. So, and again, the results are crowdsourced. And so let's talk about crowdsourcing a little bit. By getting the users running tests just from the website, for one thing, it's really easy to participate and it's really easy to collect data. Another is that this gives us a way to be super current. A nightly comes out, maybe people are even automating testing their nightlies with Selenium. Who knows what's going to happen once this has been up for a while, but as we can see from the list of browsers, which I'll show you, it happens very quickly. We're able to cover a huge spread of tests on a huge numbers of platforms really quickly, much more quickly than you could do that yourself, and because that's really hard. So aggregating results here by taking medians over a large data set, this helps to reduce selection bias. And like I said, the new browsers will show up immediately. So this is our big call to action on the front page, saying how does your browser compare? And so far, people have shown this too. They instantly understand what this means. They can come to it. They maybe don't understand the nuances of the tests themselves, but they get it and they're participating. So this is an example of a trend analysis, the kind of stuff that we want to do on the site. But this was done actually out of Google Spreadsheets. So we just took all the Firefox minor versions, put them on the x-axis here, and this is the network test. This is Steve's original UA Profiler test suite. And of course, Browserscope is pretty much based on the idea of UA Profiler. All the crowdsourcing and most of the logic behind how to do that is based on that project. So this is Steve's data, and you can see immediately up and to the right, which is good. That means two things. One, probably Firefox is paying attention to this stuff on the web. I mean, they're doing a lot of things, but they're also fixing these issues that Steve's identified. So that tells you that having these things visible, results in them being changed, which is kind of what we want. We want to be able to highlight things that we think browsers should be fixing. And of course, like every large organization, they have 1,000 things to do, and we're just trying to give them another input in terms of priorities. Working in Buganizer, I know I have a huge list of bugs. So sometimes priorities are a little, it's good to get feedback from the outside world about priorities. So here you see, Firefox 3, they're up to 8. And then by 3.05, all the way up to 3.13, they had a regression in one of the tests. And do you know which test it is, Steve? Caching redirects. So, interesting that you can kind of see. I don't know why that happened, but it is interesting. Maybe Steve, it was a bug. Okay. So, this is something where, Steve's test really picked up on that, and it lingered for, several versions, and then gets fixed again. And of course, you can see this trend. They're fixing a couple things at a time, and come Firefox 3.6, I think Namaroka is the code name. They're passing all 11 out of 11 network tests. And I think Steve was telling you they blogged about that, and they're proud of this fact. And that's what we want, is to find tests where the browser vendors are proud to pass them. So what are the tests? What are we testing today? So we have Steve's UA profiler tests, which we've put under a category of network performance. And hopefully we'll be adding to this test suite. Like, we have 11 tests now, but there's nothing to say that number shouldn't go up and we shouldn't try new tests. But again, the point's to pick important ones that we really think browsers should fix and put them in the test suite. Annie Sullivan here at Google wrote a test for rich text edit mode based on a pain that she deals with working on the WYSIWYG editor that's in most of our products. Essentially, if you cut and paste bold from one browser to your email client, and then you cut and paste back into your browser, the results can be very different. And I'm sure you've all felt the pain of cutting and pasting into browser text editors and seen, why doesn't it do this? Why can't I unbold something? So Annie wanted to really highlight the problems there and wrote a whole test suite to test that. And that's new with Browserscope. ACID 3 was written by Ian Hickson for W3C, and this test suite is a very complicated test, but trying to test even future capabilities, and it's sort of bleeding edge in some regards. But now browsers are hitting the 100 out of 100 mark. WebKit's hit it, and so I know that this is a big deal. And he has a long list of sort of detail around what ACID 3 is good for on his site, and it's worth reading. But essentially, it's popular enough and people know it, so it makes a good thing to have on Browserscope. But again, it's testing JavaScript, CSS, rendering, quite a lot of things. The last one here is the Selectors API test suite written by John Resick at Mozilla and the author of jQuery. John wrote a whole test suite for testing the new upcoming query selector all syntax that will be in browsers, essentially, which looks like CSS selectors as a way to get at nodes. So, there's a syntax, a lexical syntax for what you can put in that selector and what should come back. So he's actually written a test suite, and now we have data about how browsers are doing against that test suite. In the future, obviously, we want more categories. Here we've listed reflow. Browserscope, for me, came along because I spent a lot of time trying to profile reflow in browsers. It turns out that's very much a performance metric, though. And so until we've come up with a way to solve with probably some kind of linear regression or something, the selection bias issue, we're not going to publish that data just yet. But I spent a lot of time analyzing reflow. Cookies and how browsers handle cookies. Security is an issue that we could probably do some automated testing for. I spoke with Raman this morning downstairs about adding some accessibility tests. So I think that there's a lot of categories here that people will get excited about as this gains popularity and gets visibility into the browser vendors. So I wanted to talk a little bit about some of the architecture and challenges, just because it might be interesting to you all as engineers. Of doing a project like this. One of them is just scaling. We want to be able to handle a whole lot of input at once and not go down. And so, we're running on Google App Engine today, and that's conveniently very good for scaling, but it is a challenge because you have to set up your models in a certain way to make that work. So we're making use of the parent-child entity groups in App Engine, because with those, you can have a relationship with one-to-many, say, and then bring that down into a transaction so that you can add things and make sure you're not losing data. Or, and in the back end of Google App Engine, when you do a transaction, it's trying again until it gets it done. So this ensures their data integrity is staying intact. We're making a lot of use of the new task queue that's in labs for App Engine. And task queue pretty much does everything for us because our system is a median system. So we're taking all this data and coalescing it down into a median. Well, if you're in a SQL database, you could just call the median function. App Engine doesn't have a median function, so we're maintaining a median tree in the data store and in memcache. And that takes a lot of task queue operations to do correctly. I was just talking to Jacob here, who, actually, I wanted to mention, since we're there, Jacob Moon had ported the ACID 3 tests into Browserscope, and we've been talking about some of the challenges there. One of them was that ACID 3 is a really particular test. when Jacob started to ask Ian about how to port it, he was like, oh man, you're going to have a hard time. It's very dependent on a bunch of different variables. And of course, Jacob went away and did it in, I think an hour, just because he's that good. But other things that we hadn't thought of are things like we were running ACID3 in an iframe, and it turns out in Opera 10.10 and some versions of Opera, doing that test in an iframe actually yields a different result than just running it in the window object. So just going straight to the page. And a bunch of Googling and torturing myself led to the conclusion that, maybe Opera just doesn't handle iframes very well. Sure enough, running it in a frame set works perfectly. So now all the tests run in frame sets. But this is, just one of probably many challenges we'll come up with trying to run these tests. User agent string parsing, obviously that's a big part of this project because we're grouping and sorting and ordering things by user agent string. And parsing user agent strings today, there's not really any single source of truth for how you should do that. And so we're actively seeking out somebody to take on this project, sort of take it outside of Browserscope, work on it, and make Browserscope a consumer of this. So we're working on that. And if you're interested, please let us know. And probably the last and certainly a big challenge with this project is how to display all this data, because we want people to come and instantly run the tests, but we also want to appeal to browser vendors so that they can go and run individual tests and fix things. So this is a very different user group, and it is a lot of data. So just how to display it, and I think that's something we'll be experimenting with a lot over the next 6 months. Just sort of a roadmap of where we're heading. We want to put something like a wall of fame or trending where some browsers quickly improving and try and give them some visibility for that. Obviously, getting more contributors and test categories is big for us. Being able to tag or personalize your test results. So say you do want to run all your tests on a particular piece of hardware and be able to analyze how those happen. We want to enable that. Normalizing time-based results across platforms, as I talked about before. If you do have millisecond data, there's an inherent selection bias around where that, how that data looks. So, for instance, Safari on a Mac is always going to look faster than IE7 because of the hardware variance. So, I say always. It most likely will. Apple Macs are really nice pieces of hardware, so those millisecond times aren't really absolutely comparable. But we can solve this with some linear regression, and we're going to work on that. And trends. So these are some links to different parts of the project. And I want to go back to one other bit that's on our project homepage and highlight that for you. So last night, I decided I'd stay up really late because I had this great new feature to demo for today's presentation. And I woke up this morning after sleeping for 5 hours, and I thought, wow, that was phenomenal. So anyhow, in an effort to sort of play along with the Google data liberation that's going on, where basically we're putting data out there, we now offer downloads of the data in both CSV and Python pickle format. Obviously, JSON and other sorts of dictionaries make good candidates for future downloads. But, and also adding some roll-up statistics here. So I just wanted to go look at the roll-up statistics with you for the all versions pages. And you can kind of see how Browserscope works. In the back end, we're caching all of Browserscope's data at a row-by-row level. So when new user agents come in, it only breaks the mem cache for that row. So that's how we're able to actually even deliver this page. So just some other highlights. You can sort by score here and go down and see. Oh, there's IE4. I mean, who'd have thought somebody would have run this test in IE4? But that's kind of fun. So as we go to the bottom, we can see the network tests. We have 30,000 test results in the network category with 441 browsers. That's a lot. That's pretty hard to cover in your test lab. So the numbers are pretty good. Now, granted, we did import this data from Steve's UA Profiler project. So let's look at the rich text tests. And let's look at what the spread is of this, because this has only been up since Browserscope launched. Oh, come on, my cron job. Oh, we'll have demo fail. Well, okay, let's look at the selectors tests. Or ACID3. Okay, let's look at the all versions tab here. And we can look at how many tests have come in just since we launched. And how many browsers? The launch was on Monday, so 3.5 days ago. So we've had 6,500 tests and 139 browsers in just a couple of days. So that's a pretty wide spread, and that's just, a lot of conference attendees when Steve announced it and people just seeing it on the internet. So that's a pretty good metric for early part of a week, I'd say. And so, this is the numbers here, what's going to make this powerful. So anyway, thank you very much, and I'd love to take your questions.
So I was curious if you found any flaky tests and how you deal with that data.
Yeah, that's definitely an issue. The question was, have we found flaky tests, and how do we deal with that data? I think that's one of the designs for the system was to be able to accommodate that problem. Because let's say, tomorrow, Annie's got 170 tests or something, or 200 tests at now. What happens when she wants to add a test? What do we do? Or what happens when test number 160 is bogus all of a sudden? So every test has a function that can calculate the score for the row. And so it's as simple as just making this one function in every test set be able to go, okay, actually we're going to ignore test 175 and not count it in the median scores. Or if a new test comes up and we don't have data, we won't penalize the score for that row. And as far as flaky tests, I think we're trying to avoid that as much as possible. If we have flaky tests, I think we should take them out.
I was thinking along the other side of the browser is flaky in this, for this particular test. It's got
I hear you. Most of these medians solve a lot of that problem. I mean, what we really care, it depends on how far what the variance is like there. But since we get so many test results, medians should give us something closer to the truth, and would be a good reason why reading one person's single browser test for that wouldn't be so great. Yep.
If you have a branded version of a browser that reports itself in the user agent string, is each of those a separate row, or do you try to figure out what it really is?
So the question is, if we have a branded browser that reports itself differently in the user agent string, and how do we deal with that in the row? And are you talking about an example of completely changing it, like say you're in Opera and you go to the configuration and you set it to look like IE6, or something more nuanced?
No, it was a trend for a while for ISPs to, here's your specific
the
ISP.
Comcast Yahoo browser.
Exactly, and it's just a very lightly skinned version of some other browser. Would it show up, each of those show up as a row in the table, or do you try to collapse them and figure out what it is?
I think we would try to collapse them and figure out what they are, but also it depends. I mean, right now, I don't think we have a great answer for that question, because it's, I think we want to defer that to once we really parse out every bit we can. If we can distinguish it, I think we should distinguish it once you get to this all versions page. We might roll it up into the major version of a row. But once you get to the all versions page, we really want to show as much detail as possible. And also, we want to be able to split this out by platform, and that's something that's coming soon too, to be able to see, wow, is Firefox on Linux, does it do something differently in one of these cases? So I think we want to provide as much detail as we can possibly get out of that data, especially if it's useful to someone. Okay, Josh?
Am I coming through from New York? Hi, thanks. I was wondering, is there any possibility of recording what extensions are in the browser? Because that can affect some of these test results in significant ways.
Yeah, I think one of the things, by not doing performance stuff, we're less likely to get affected by that. But when it does matter, I mean, you can get, anything you could get, we could try to get. We could add a JavaScript test down at the base before we send data to send back as even more info than is in the user agent string. And we're gladly accepting contributions to that end. Hint, hint, wink, wink. Okay, I'm going to pass this off to Steve to talk about SpriteMe.
I wanted to relay two other anecdotes about Browserscope. One was, I think we were kind of fortuitous in the selection of the 4 test categories that we launched with. Two of them are pretty well recognized, ACID3 and Resig Selectors API test. And so when people look at Browserscope, they immediately, have an idea of what it's trying to do. And then the two other categories, my network test from UA Profiler, and might be a little recognized, but they were totally homegrown. And then Annie Sullivan's tests for rich text edit controls are brand new. And so I think that kind of shows how we can look at tests that are established and well understood and still have a benefit of weaving those into Browserscope. But then there's also this big opportunity for things that aren't touched up on at all out there to code that up, and it's not that much work, and start tracking it and sharing that with the rest of the development community. And that's a segue into the second anecdote about Jacob adding the ACID3 tests. I went to one of the regular Browserscope meetings, and that was the first time I met Jacob. And he demoed, he had found the project without really talking to Lindsey or I or anyone else or working with us, had found the project, downloaded it. He had some App Engine experience, which helped him. That was one of my stumbling blocks. And he just added the ACID3 test, and it didn't take him that long, and he comes to this meeting, first time I meet him, and he demos it, and it was like, wow, that's cool. And that was one of, yeah, he added V8 and SunSpider too. And so that was our goal from the outset, was to make it really easy for other people to add test suites. And so that was kind of a positive test case that we had achieved that. Someone added 3 test categories in that case without really talking to us at all and asking any questions. So I think it is pretty easy. Certainly contact the Google group for Browserscope if you have some ideas or questions. But I encourage everyone to just dive in whole hog. Okay, so shifting gears, now I'm going to talk about SpriteMe. So let's see here. I'll just go to the website. So in May, at the end of May, I spoke at WordCamp, the WordPress conference that Matt Muhlenweg runs, and I had this idea for a really awesome talk, because I do the same kind of talks 10 or 20 times a year at conferences, and wanted to vary it up a little bit. And so I decided I was going to optimize a WordPress theme live on stage, because we've gotten to the point where a lot of the tooling is readily available and has a high degree of automation in it. And so you can run the YUI compressor from the command line as part of a build process, for example. So I of course, waited till the night before the conference to go through this. It wasn't until that afternoon that I kind of gelled on the idea. So that night I sat down and ran YSlow and page speed and came up with the 6 or 7 optimizations that would make the most sense, and pretended like I was live on stage and did these code changes. And all of the changes that I had to make took about 30 minutes. And then I got to the last one, which was spriting. And at 3 a.m., 5 hours later, I finally gave up. And it was just too hard. And so it was just amazing to me I don't do a lot of spriting, and I had no familiarity with this page, but I was doing stuff like combining images that repeat with images that don't, or combining images where the background image itself was much smaller than the containing block. And so when I went to one of the spriting tools out there, like SpriteGen, and it gave me a 0,0 background position offset, I really couldn't use that because it was making the rest of the sprite's background and other sprited images bleed through. So I just kind of gave up, but I logged that away because to me it was another place where we needed some more automation and codification of knowledge in a developer tool. And so for the last 2 or 3 months on the side, I've been working on this thing called SpriteMe. So I've got a slide deck. I'll mostly do demo, but I've got a slide deck, so I'll go ahead and jump into that. So here's eBay. eBay's my canonical example. You can see I've run SpriteMe here, and I'll actually demo this more, but I just wanted to throw this up to highlight the 5 main features of SpriteMe. It finds all the background images and elements that use them in the page, so you can survey the current state of a page very easily. It has the logic of knowing what to group together, so you can avoid all of those dead ends that I went through when I was trying to optimize that WordPress theme. It actually generates this sprite. There are other tools out there that do this. Once you know the images that you want to combine together and how to group them, well, then you can use some of those sprite generation tools. But that's actually one of the easier parts of spriting. It's all of this arcane knowledge about what you can and can't group together and how to arrange it vertically or horizontally, etc. And then the really cool thing it does is those other tools give you updated background positions for the sprite, but they assume everything has a 0, 0 offset. And like in my case, when I was doing this WordPress theme, almost nothing had a 0, 0 offset. So I did a quick survey of the Alexa top 10, and out of it's about 700 DOM elements that have background positions, less than 6% of them have a 0, 0 background position. And so these tools that just tell you the background position, assuming a 0, 0 offset, don't really help in over 90% of the cases. You have to do math. It's scary. And then the other thing that SpriteMe does is it generates this new sprite with these new background positions and actually updates the page while you're looking at it. So you can visually verify that that sprite and the background positions are going to work and not cause any visual change in the page. And for anyone who's started in a new development environment, you know that your number one goal when you're just getting started is to figure out what you have to do to reduce the edit, save, compile, test cycle, to minimize that to be as quick and as short as possible. And so with sprites, we didn't have that situation. You had to figure out what to sprite together, you had to run it through some spriting tool, you had to download that image to your server, change the URL for the background, integrate these background positions, and reload the page. And if you got it wrong, like repeating that whole cycle would take 15 to 45 minutes. Whereas in SpriteMe, I ran it on the Alexa Top 100, and for about 80% of the pages, I could take SpriteMe's recommendations out of the box, and it produced an optimal experience. And for the other 20%, I could see that it was making the sprite image too big, egregiously, 50K larger than the background images had been before. And I'll talk about that in a minute, but I was able to easily, and I'll just dive into the demo, easily rearrange the SpriteMe recommendations to produce a better result. So let me go ahead and run SpriteMe. Again, actually here, I'll start on this page. So you can go to the front page. It's a bookmarklet, so it's really easy to install. You just drag and drop this up here. If you're in IE, you have to right-click on it and say Add to Favorites. And now you can run it on any page you go to. And so here's SpriteMe. Last night I added making the window draggable and collapsible, so that was cool. I was up till 2. I think Lindsey was up till later than that. And it's got these recommendations, right? So you can hover over any of the background images in the page, and you can actually see what that background image looks like. Here's the background image that's repeated horizontally for this little header. And if I expand any of the images, I can see the DOM element or elements that use that background image. I can hover over it and it actually highlights it in the page. And if I click on it, it will run Firebug Lite, also a bookmarklet, so it runs in all browsers, and will show me that element, and it will show me the CSS. So sure enough, this one is using this background image called Logo 6464, right? So now, let's see, let's close that. All right. So now what I can do, here's a sprite that was recommended by SpriteMe. It didn't include this one because it's quite a bit larger than the other ones, and SpriteMe's trying to avoid increasing the memory footprint of the sprite, but it's only 64 pixels wide, so I can just drag and drop it up there and modify the SpriteMe recommendations. And now to actually create the sprite, I just click on Make Sprite. So it's going off to a web service, and I'll talk about in a second. And now I have this new sprited image called SpriteMe1.png. And you can see it's got all the combined rounded corners along with this background image here, and shows me the resultant size. In this case, the file size is still pretty small, and the memory footprint of such a small image is going to be minimal. And now, if like I expand this and look at the DOM elements, I can see all of the DOM elements using this one. If I click on the site header again and look at it, now what we see is the background position has actually been updated. And if we look at the background image URL, it's using this new one. So SpriteMe has actually updated the page in real time, and so you can like minimize SpriteMe, and you can visually check that the page is looking the way that you want, that you've preserved the visual look and feel. I wanted to show another feature here that occurred to me, and I think it's really cool. So SpriteMe decided to combine these horizontally repeating repeat X background images together. And normally, if you're combining repeating images, if they repeat horizontally, they have to be the same width. If they repeat vertically, they have to be the same height, and you can sprite them together. But in this case, we see these horizontally repeating ones are not the same width. One is 10 pixels wide, and one is 5 pixels wide. So YSpriteMe actually suggested to combine these together. So SpriteMe just has this simple concept of wiggle room and a least common multiple capability. Again, it's that math rearing its ugly head. And it's decided that it can, without too much increase in the size of the sprite image, it can just double the width of this smaller background image, and it will make the overall sprite 10 pixels wide. So I can do that. So like if I look at this gray one is 10 pixels wide, this purple one is, or reddish one is 5, it's a little narrower. But when I make the sprite, the result is the purple area has been doubled in width. So now these can be sprited together. So with a little image manipulation there, I can save another HTTP request or a couple of them. So now let's go to eBay and look at that. I've got to email these guys and let them know about SpriteMe. So we see we have a lot of opportunities for spriting. 3 different sprites were suggested. And so I can just go ahead and, here's this one. I know this one, it's the background for the buy button up there. I can say make sprite. This one's going to take a little longer because what's happening is the request is being sent to this web service called Cool Runnings, and it's downloading all of those background images from eBay, spriting them together, and returning the image to SpriteMe. And so we can see we cut 14 requests. The size of the images has increased by 7K. That's certainly a good trade-off, but we actually hope to start seeing, with a few other changes I'll talk about in a minute, start seeing reductions in overall image file size. And again, we can see the resulting sprite, and if I expand the list of DOM elements, there's that buy, and now it's using the new sprited background image. And we can look at the page, and it hasn't changed at all. The visual look and feel has remained the same. We can make some other sprites, and we can see that we actually did reduce the size with some of those other sprited images. So we eliminated 18 HTTP requests and only had a 2K increase in size. So that's an awesome trade-off that would make this page a lot faster. There's this little button, share your savings, so I want to issue 2 warnings that I didn't think would come up, but people have emailed me about it. So one is, when you create the sprite, like I said, it's using this web service, this offsite web service, and it's sending the URLs of your images, and that web service is trying to fetch them. So if for some reason the URL of your image is something secret that you don't want anyone else to know about it, then what you can do is you can download and install a local version of the Cool Running service. It's open source, and get around that issue that way. And the other thing is there's this share your savings button. And when you do that, now if we go and click on that, there's this savings page. And so this is a place where I wanted to gather some stats and have people elevate the impact that SpriteMe is having on pages or potentially issues that SpriteMe is having. And so here you can see it took my results and sent it up here with the URL. So if you're running this, again, on some like secret website and you don't want anyone to know the URL, then don't share your savings and publish it to the rest of the world. Okay, so let me go back to the slides and wrap up. So that's a quick demo of SpriteMe. Oh, wait, I want to do one more thing. So, when I build these, browser plugins, I always start with the same progression path. I start building it as a bookmarklet because that means it's going to run in all browsers. And then if I run into restrictions, I might run it, or something that I want to automate to some degree that a bookmarklet won't let me, then I go Firefox and I do a grease monkey script. And if I need to get past some security restrictions, then I build a Firefox extension or add-on. So in this case, I've been able to do all of this with just about 1,000 lines of JavaScript code, and it runs in all browsers. So I just left it as a bookmarklet. Later I could definitely see like integrating this with some browser plugins, but having it as a bookmarklet means it runs in pretty much all major browsers. So here's Chrome. I can run SpriteMe, Sprite it, IE, and Safari. There's a little, it pretty much works in Opera. There are a couple cases, like the eBay case, where the background positions aren't being computed quite right, so I still got to work on that. Okay, so it works in all browsers. That's cool. Okay, so what else? So here's the savings. So we can see across, I ran it on the Alexa Top 100, and it's actually kind of cool. On average, across these 100 sites, or about 90 sites after I remove all the porn sites, there's about 2 sprites. So people are already using sprites to a fair degree, but even though sprites are being used, on average across these sites, there are 9 HTTP requests that could still be eliminated if the background images were sprited the way SpriteMe suggests. Now right now, the overall result in terms of file size is a 6K increase, but I'll talk on the next slide about some ideas for how to make the overall file size and footprint size smaller. So one is, we're running this on just our personal web-hosted servers, myself and Jared. And so for the launch, that was just a few days ago, we had a little concern about, getting overloaded. So Jared's using Ping Crush on the Sprite service, image spriting service, and it has an optimal image compression level, but he actually backed off on that and took a less optimal one. So once the Slashdot effect is over, we can crank that back up and get some savings there. But there's also some other things we can do, like the biggest one, jumping to the third bullet, is crossing the 255 color boundary. So right now, SpriteMe doesn't have any knowledge of the colors that are being used, how many and how they overlap or are disjoint from other images in the page. And so that's something, right now, like I said, about 80% of the time, SpriteMe suggestions are fine. But that's a case where if you create a sprite that SpriteMe suggests, and it like really jumps in size, reload the page and go back and look at and try to create a new sprite. I didn't show that, but you can create a new sprite and then start grouping things any way you want into that new sprite. And so that's what I did with some of these top 100 sites, is I found like there was a big jump in size, and by grouping just visually without knowing anything about their images, I could just tell visually, oh, these are mostly blue, these are mostly orange, let me separate them into separate sprites and try to avoid crossing that 255 color boundary. Once you go across that, the image size is going to get bigger. And then there's a memory footprint issue. Even though the size might be small, if you create an image that has a lot of white space, that's got large dimensions, the overall dimensions are large, but it has a lot of white space, the white space will be compressed nicely with the image formats, especially PNG. But when you read it into memory, the browsers, at least IE and Firefox, I think, convert it to like a bitmap format. So every pixel of the background image is actually taking up memory. And right now, there isn't any logic in the Sprite image creation service for how to arrange or pack those images to reduce the overall dimensions. So that's something to work on. There's a lot of logic behind, this arcane knowledge of how to create sprites. There's a lot of logic embedded, but there's still more to be added. And if you go to the project's website, you'll see bugs for all of these. But for example, if you have an image that repeats and you have another sprite, right now, repeated images are never combined with non-repeating images. But if the repeating image, for example, if your non-repeating images are in a vertical sprite and you have something that repeats horizontally and the width of that horizontally repeating sprite is wider than the vertical sprite, you could actually add it and combine repeating images with non-repeating images in a single sprite. There's a couple other test cases here. Right now, there are a lot of options that are hard-coded into the JavaScript, like what the background color should be, these wiggle room settings. You might want to be more aggressive or less aggressive. The issue is it's really hard to set options and save those in a bookmarklet. So I've got a couple ideas of how to do that and hope to add that soon. And another request is you might want to sprite some background images from page 1 with some background images from page 2, because those pages users frequently go to in the same session. And right now there's no concept of like running SpriteMe across multiple pages. So that would be a nice feature that people have asked for. There are a couple of big ones. Right now, SpriteMe only looks at CSS background images. And although we see that, on average, we can get about, almost 10 HTTP request savings, by far, regular content or IMG images are much more prevalent in web pages today. And there is a way that you could sprite these IMG images, but it requires more changes to your markup. So I'm going to try to investigate how to automate that and make it as easy as possible for developers to adopt this technique. And it actually is a preferred technique over CSS background images, because CSS background images aren't displayed progressively. So if you have a large background image, nothing is displayed until the whole thing is downloaded, whereas IMG images in the page, browsers do draw progressively. This is a really cool idea. So like one of the real pain points of sprites is maintenance. And so once you create the sprite, if you want to replace one of the 32 icons in there, that's going to be difficult. So one idea Jared and I have is when you create the sprite, in the comments of the PNG, actually put the original background images offsets, upper left, lower right, so that then we could write a special sprite image editor that would put boundaries on each of those separate sub-images that were combined together, so you could easily swap one out without affecting the layout and background position in CSS of any of the other images. So we'll be thinking about that. Another one is I really like this, this metaphor of updating pages in real time and giving developers real-time feedback and cutting down on that edit, save, test cycle. And so another idea I had, we could do this with something like ImageMe, where Google PageSpeed gives you suggestions about how you could optimize images and actually produces those, but it doesn't put them into the page. And those recommendations could actually be swapped out with the images in the page, so you could see that all of these optimizations that PageSpeed does are lossless, but you could actually test it out and visually confirm that the optimized images were to your liking. So I mentioned Jared's name a couple times. This is a testimony to open source. Like I found him on, I think, the Yahoo Exceptional Performance mailing list. He had this spriting service. I needed a web service. I asked him to make some changes. He did it, and we got this whole thing working, over email and a couple con calls. So I want to thank him for running this cool running spriting service. And Brian McQuaid, who works here at Google on PageSpeed, he and I had a couple conversations about this way of spriting foreground images. So I want to thank him. And there are the usual URLs. So that's it. I've got time for a few questions if anyone has any.
So eBay and WordPress, for that matter, the images it displays are very dynamic. Do you think the sort of work that SpriteMe is doing is suitable as like a pipeline stage at the end of their content management, or is that just the wrong way to approach it for them?
Yeah, so the question is kind of around websites where the images change a lot. So you think about like the front page of YouTube. Why are there a lot of video thumbnails that aren't sprited? And actually, maybe they are sprited. But like that would be a case, or like a news site like CNET, where the images, a lot of the images are changing every 5 minutes or 15 minutes. So the first thing I would say there is they're probably having a lot of images change, but they're probably not background images. Typically, the background images have to do with the adornment or wrapping around the page, the buttons and things like that. So those don't change that much. But if you did have cases where you were using these very kind of dynamic images as background images, or if and when SpriteMe gets to the point where it can sprite foreground images, I do think that we're going to see back-end plugins where people can create sprites, people that own websites can create sprites on the fly. So if YouTube doesn't do it already, they could build some back-end that would say, at this second of the day, we want to show these 12 video thumbnails, and it would actually, rather than put 12 separate HTTP image requests in the page, it would sprite those in real time and just serve one image to the page. And I know sites where they've already built that, and it works really well. It's not easy, and certainly I think a year or two from now, we'll start seeing capabilities for that in more popular frameworks. So I think it does make sense. Any other questions? All right, thank you very much. Look for it on Web Exponents. See you later.